Welcome to Lecture 4.4. So far we've talked about the development of locomotion and ballistic skills, and we're going to transition to talk about the development of manipulative skills, which are basically manual skills. Manual control is very important in our day-to-day lives as we utilize our hands for many activities of daily living, such as eating with spoons and forks as well as eating with chopsticks. We only really realize the complexity of manual skills when we study robots and we're trying to control them to reach and grasp for objects. We'll be going over the importance of manual control and how we control hand movements in this lecture. Prehension is the act of reaching and grasping for an object. The typical progression of prehension starts from 1 to 6 months and starts with waving and banging in the first 1 to 4 months. By 3 months, there are reaches that take place, but in a jerky zigzag motion. By 4 to 6 months, we expect the reaching pattern to smooth out and become more direct towards the target object. Going back to our theoretical perspectives, the development of prehension can be explained in 2 ways. From the maturation perspective, the maturation of the CNS drives the development of reaching. From the dynamical systems approach, prehension develops and emerges from an interaction of organismic, environmental, and task constraints outlined by Newell's model. In addition to the reaching pattern becoming smoother, there is a change in the grasping pattern that occurs as well. From the traditional maturation view, the changes are documented by age, since maturationalists believe that the change is driven by the nervous system development. As children move through the first year of life, they switch from a palm or palmar grasp, where they use their thumb and the whole hand to grasp an object, to a thumb and forefinger grasp, which is more precise. There is a general pattern from the palmar grasp to the use of fingers as the progression of development takes place from the ulna to the radial side of the hand. One of the traditional approaches to prehension development was studied by Halverson in 1931. He created a study where he created the classical experiment where he had infants pick up a 1-inch cube. They identified 10 different stages of grasping in infants from 4 to 13 months, and at the first stage of grasping, infants cannot change their grip to accommodate for different objects. We can see in this diagram some of the changes in grip that take place through development. Infants start with the palmar grasp and begin to develop more manipulatory skills from the radius to the ulna, and eventually develop the manipulatory skills needed to effectively use the thumb and forefinger grasp. We'll now talk about the constraint perspective on the development of prehension. One of the primary prerequisites for prehension is postural control, as the development of good posture and the ability to maintain good posture influence the emergence of reaching movements. When studying early reaching, researchers found that gravity has an effect on the early reaching behaviors of an infant. They created an experiment where they had 2 age groups of infants and placed them in 3 postural orientations. Since these were different groups of infants of different age, the design was a cross-sectional design. The orientations were 0 degrees, where the infant was on their back, a 60-degree reclined chair, and a 90-degree chair that forced the infants to sit directly upright. The dependent variables that were looked at were the number of reaches, the duration of reaches, the starting arm position, the location of the touch and grasp balls, and the closure of the hands. They found from this experiment that the younger children produced more reaches and reaches of longer duration compared to the older children in the 90-degree configuration. So you can see here that in the supine and the recline position, there were less reaches that occurred compared to when they were in the vertical 90-degree for the young children in both number of reaches and the duration, indicating that the postural control does affect reaching behavior. To summarize this study, In the supine position, infants have to overcome gravitational torque more so than they do in the vertical position. And this graph shows us that children had more grasp in the vertical compared to the older children. So in the supine and recline positions, infants have to overcome more gravitational torque than when they're in the vertical. The implication of this study is that reaching behaviors are not only regulated by age, but by the environmental constraints that play a crucial role in reaching behavior. When comparing the maturational constraint perspective, we have to take into account that the Halvorsen study did not account body scale when studying infants of different ages. A study done by Newell had objects of different sizes, textures, and shape in order to see if the objects that the infants needed to grasp had an effect on grasping behavior. Here, the sizes and shapes and textures would be considered the task constraints of reaching. They did a qualitative analysis of reaching in the study and characterized whether or not there was a reach, and then distinguished the type of reach that occurred and whether or not the reach was performed with one hand or two hands. Based on the study, they found agreement that infants change their grip based on age. They also found that infants changed the grip configuration based on the object constraints such as size and texture, rather than changing the grip configuration only when they grow a little bit older. They found that based on whether the hardball or softball was reached, also influenced reaching. When using a hardball, there was reaching but no grasping. But when the ball was softer, there was more reaching and more grasping took place, but only for the smaller sized balls. They also found that an effect of shape, as the infant showed earlier onset of grasping in the toy cup compared to the ball. This tied back to our previous lecture because the shape of the cup affords grasping more so than the ball does. Additionally, let's take a minute to define the difference between a power and a precision grip before we move on to our next round of results. A power grip is a full hand grip that's used when grasping larger objects. All 5 fingers are involved in the power grip, and this differs from a precision grip because a precision grip is basically a thumb and forefinger grip and is used to grasp smaller objects. The differentiation between when we use each of these grips is dependent on the object and the child's ability to distinguish the object properties when grasping the object. We'll pause this lecture here and we'll talk about the rest of the results of that experiment in the next lecture.